You find yourself in a foreign city, alone, and you need to get back to your hotel. The sun has already set. You don't have a car and can't get a taxi, but you don't need one. You are tough. You rummage through your pant pockets and find a mobile phone. With that, you have access to the internet. Suddenly you remember that this city is not safe after dusk. You might get robbed, or worse. But you don't panic. Not because you have a black belt in karate. It's because you got Final Destination. Final Destination is a mobile application that gathers crime reports and map data from online sources to combine them. In this prototype implementation, we use crimespotting.org and spotcrime.com for up-to-date crime reports and Google Maps API for map data and route suggestions. Suppose we want to go from a house in Home Park to the Arts Center MARTA station at night. Google Maps probably would suggest this route. From our data sources, however, we know that this is a rather dangerous area after nightfall. A lot of crimes have been recorded recently, as the pins show. With this data, we can generate a heat map of the area, green being safe and red being risky, assuming that the recorded crime density is not just coincidental. Now this route doesn't look very appealing anymore, does it? We would rather go around the dangerous area, even if that takes a farther walk. Unlike Google Maps, Final Destination will help you find a route that's not merely short, but also safe for walking. Let's take a look at Final Destination in real action. The application uses the familiar Google Maps interface. The user chooses the start and the destination as well as possible stopovers by selecting on the map. The route is calculated and displayed in a color code showing dangerous sections. By selecting further points on the map, the route can be recalculated with a detour through that point. That way, the user can figure out viable alternatives. So what's the architecture behind Final Destination? The client is a web application built with Google Web Toolkit. It contains both the user interface and the calculation logic. The web application is wrapped in PhoneGap, making it available for all major mobile platforms. The client fetches both the maps and the directions from Google Maps API. The crime records, on the other hand, are fetched from our own servlet running on Google App Engine. For storing data, we use Java Persistence API. The server aggregates the external sources for crime records, such as Crime Spotting or Spot Crime, but other sources could also be added. There were mainly two problems we faced. First of all, the Google App Engine has some limitations we had to deal with and does not provide a complete Java EE environment. The second one was the Java Persistence API, with which we store the crime records. It doesn't provide the full features of an SQL database, which inhibits the performance to a certain degree. To improve Final Destination, more crime record sources could be added to make Final Destination available and more accurate to more places. We also suggest integrating traffic data, as we think that busy streets are usually much safer than deserted ones. An algorithm for automatic route suggestion would surely be welcome too. Remember, you might not have the power to fight crime, but you have the power to avoid it. Use that power. Use Final Destination.